Okay, so this video to talk about division of a fraction. So we're gonna talk about, before moving on to division of a fraction, this is page 30 and 31. I want to review what we did for two types of division problem. Can anybody remember what we talked about that? For example, we have a problem 6 divided by 2. We can do two different ways. There are two different meaning. Do you remember what they were? I have 6 cookies and I have 2 people to share. How many does each person get? That's something you can try to do. 6 cookies, so do we know number of groups or number in each group? We know number of groups is 2, so we are going to share equally. So one person gets 3 cookies, second person gets 3 cookies. So this is the answer. This is one way. It is called sharing problem, right? So we know the total cookie and number of groups, and you want to figure out how many per person. That's one concept. The other one, they look exactly the same using number sentences. But this time, I have 6 cookies, but this time, I want to give 2 cookies per person. And how many people can you serve? Do you remember that? If this is a problem is measurement types of problem, grouping. I want to figure out how many groups of 2 are in my number. So I can have one group of 2, I have a second group of 2, and 3 groups of 2. So my answer is 3, but this time my unit is 3 people. So I have one, because I know number in each group is going to be 2. So I have one person I can give the cookie, and I have another group of 2, so I can give another cookie for the person, and then I have another 2 groups, so I can give the cookie to this person, so I have 3 people I can serve. So this is measurement types of problem. So we're gonna use the same concept to think about the fraction division problem, to understand what a fraction dividing means in mathematics. Okay? And also, regardless of the context, we can always talk about fraction long division. Remember that is a kind of measurement concept. We are not trying to find how many groups of 2 can fit into my 6. That's we are always trying to find out, like this. We want to figure out how many 2 can go into 6. We want to figure out how many 4 can go into 20. That's what we are trying to do. And we write this as 20 divided by 4. Right? That's what we are doing for division. So let's review and let's go back to the problem here. So in your strategy book 30, what does the problem say? So let's read the problem together. Okay, it says, super sub sandwich is starting a catering business. A child serving is 1/6 of a super sub, and adult serving is 1/3 of a super sub. If you have 6 super sub, how many children can you serve? How many adults can you serve? So what kind of problem do you think it is? Do you know the total? Yes, my total is 6 super sub, right? And I want to serve these 2 people. So first, think about the first adult one first here. Adult serving is 1/3 of a super sub, right? So do you know number of groups or number in each group? Yes, we know number per person, number in each group we know. For adult serving, we know 1/3 for each group. I want to find out how many people can you serve. That's what we're trying to find out. So think about that. This is 1 super sub, right? And I'm going to have 1/3 serving, so I can give 1 adult. I can give 2 second person. I can serve third person with 1 super sub. This is what we are going to do. So we are trying to find out how many groups of 1/3 can fit into 6. Are we good? Let's look at this one using fraction strip. So I have 1 whole, and I want to serve, so I can use 1/3 here because that's adult serving. So 1/3, 1/3, and 1/3, and I can serve 1 adult, 2 adult, and 3 adults. So using 1 super sub, I can serve 3 adults. then how many adults can I serve when we have 6 super sub? So 3 times 6 equals 18. So we can serve 18 adults. Do you see what I'm doing here? What about children serving? Children serving is because children is smaller than adults, usually. So this is size is smaller. So I have 6. This is one child. Another 1 6 second child. Another 1 6 third child. Another 1 6 fourth child. Another 1 6 fifth child. Another 1 6 sixth child. So one super sub, how many children can you serve? I know the total 1 and number in each group, number per person, number per children is 1/6 of serving. So if I have a 1 sub, I can serve 6 children. Then if I have 6 super sub, how many children can I serve? It's going to be 6 times 6, which is 36, is the answer. Right? Because one sub I can serve 6 children, and I have 6 super sub, so I can serve 36 students. So this is what we are doing for division. Have we thought about that? Why, when you give them a division problem, what do? We don't use division, we use multiplication, right? So think about this problem here. How do we solve the problem? What do? Copy, dot, flip. So we copy the first number and then place dot. What does it mean? Multiply and flip, which is 3 over 1. So I'm going to be 6 times 3, 18. Right? What about children? So 6 divided by 1 6 and copy dot flip. So what we do? 6 times 6 is 36. Oh, then this is what? This is the same as this here, right? This is what we did earlier. This is the formula. Okay, so kids can see the relationship here. The PowerPoint slide, there would kind of more explanation, so you can always we can talk about more about that. Okay, but now let's talk about another type of fraction and division here. Second type, we talk about that 6 cookies, 2 people gonna share, and how many cookies per person get. Sharing type. And we know the total. We know number of groups. We want to figure out how many per person. Right? So let's look at the second problem here. What does it say? Second problem says half of a pizza is shared by 3 kids. How much of a pizza does each kid get? Look at the picture in the strategy book there. So I have a half of pizza. So supposedly this is a whole pizza, but they only have leftover of half. So I'm going to take away half here. And how many children? How many groups? We have 3 groups. 1, 2, and 3. And we want to figure out how can you find out how much of a whole pizza does each person get? How much of a whole each person get? That's the important. How much of a pizza does each person get? So kids can do it. I'm gonna cut this into thirds, right? And then each person get 1. So I'm gonna have. I'm gonna cut this into thirds like this. Like this. So I can cut this into thirds, right? So each person get each. So Emily, Chris gets this piece, and Emily gets this piece, and who's the other one? Laura, I think, gets this piece. So I think we equally divided. Everybody got same size piece in each. It looks like it's fair. But my problem is, what's my answer? So how can I write down number sentence? This one is half divided by third, 3, not third, 3. What is my answer? This is what we are supposed to write. Half divided by 3 is what? How can you find out? So I did all the, problem here using manipulatives. I want to figure out, we cannot say answer is this. We need to figure out what does this piece represent. A lot of kids might say this is a 1/3. Why? Because I have 3 equal size piece. So my answer is going to be 1/3. Is it true? No, it's not true. Why is that? 1/3 means this is 3, right? And 1 out of 3 is right. But whenever we talk about the fractional piece, your whole is important. What is your whole? Is this your whole? No, this is only a half. So this is my whole, right? So compared to my whole, this is not 1/3. This is what? This is 1/6. So my answer is going to be 1/6. How do I know? I would need 6 of this to 6 of this to have my whole, right? That's how I know. This size of piece represents 1/6, not 1/3. Does it make sense? Suppose the kids keep saying this is 1/3, then you can show them how many 1/3 are in my one whole. 3. So 1/3 means if I have 3 of 1/3, it's going to be 3/3, which is my 1. Right? But if you have 1/3, 1/3, 1/3, I only have 1/2. This is not even my one whole. This is not correct answer. So whenever we have your fractional piece, we have to figure it out. What does this piece represent compared to your one whole? Does it make sense? So that's why this is 1/3, not 1/6. Okay? So using this knowledge, I want you to solve the problem, and then we're gonna share together. I'm gonna share the video. But look at the problem A here. The first types of division, measurement division type here. 2/3 divided by 1/3. So I'm gonna show you. 2/3 divided by 1/3. So I want you to think about what's the concept here. How many 1/3 can fit into 2/3, right? How many times 1/3 can go into 2/3? How many times? 1 time, 2 times. So my answer is 2, right? How many times this number go into this? So I have 1/3, 2/3, 1 time, 2 times. So my answer is 2. The same as you can do the flip, copy that, flip. Oh, sorry, this is 2/3. And copy that flip is going to be 2. So my answer is 2. This is what we are doing for division here. And fraction is division too. What is 1 divided by 2? Is 1/2. So fraction is division. What is 2 divided by 5? 2/5. So fraction is division. So you can also write down this as a division here. And you can count common equal size piece here. We have 2 here. And the same size is 1. My answer is 2. This is what we are doing. So once you find the common size paper here, it's all easy. Let's do one more. And I want you to do, let's do C. I want you to do B and D. C. So this time I have 2/3 and 1/3. So I have 1/3 divided by 2/3. So it looks like this time, this number, I want to figure out how many times these 2/3 can fit into 1/3. Can you fit 1 time? No, this is too big. I cannot fit 1 time. So it's going to be only half of this. I can fit it here. So my answer is 1/2. Or you can say I have a 1 box on top and 2 boxes on the bottom. So my answer is 1/2. This is what we are doing for division problem. But if you want to do formal algorithm, copy that, flip, 1/2. Okay, so I want you to think about, I want you to figure out, solve the problem B and D from your strategy book. And same thing in here. And then I'm going to post the answer key, see if your strategy was correct or not. Does it make sense? So this is important. Conceptually, they need to understand why we are doing this. Okay, I want to talk about more about this during the answer key.